Deep beneath the ocean's surface, an invisible specter glides silently, leaving no trace. This is the Virginia-class submarine, a marvel of military technology with the power to change the course of war in an instant. Can you imagine a weapon capable of attacking an entire fleet without anyone ever knowing? With the ability to operate for months without surfacing, this submarine is not just a mobile fortress, but a hidden ace beneath the waves. Amid tensions in the South China Sea and the looming threat of conflict over Taiwan, could the Virginia-class submarine be America's strategic weapon in a showdown with superpowers like China and Russia? Join Navy power in uncovering the secrets behind its formidable strength. From the very beginning, the Virginia-class submarine was designed with a clear goal: cost efficiency without compromising cutting-edge advancements. Only two shipyards in the United States, General Dynamics Electric Boat and Huntington Ingalls Industries, possess the expertise to construct nuclear-powered submarines. These are not just powerful war machines, they represent strategy and innovation in the 21st century. Have you ever imagined that just designing a single class of submarine could take up to 35 million labor hours? And what about building one? Over 9 million work hours with contributions from more than 5,000 suppliers worldwide. What makes this project so massive? Each Virginia-class submarine is not just an engineering marvel, but is expected to carry out 14 to 15 deployments over a lifespan of up to 33 years. Impressive enough? That's not all. The U.S. Navy is not stopping here. These submarines are planned to remain in operation until at least 2042, with later produced vessels potentially patrolling the seas until 2070. Could these be the time-defying machines we've been searching for? Imagine the first Block 1 Virginia-class submarine, measuring 377 feet in length, 34 feet in width, and weighing 700 to 800 tons when submerged. From Block 1 to Block 4, these dimensions have remained largely unchanged. What makes these submarines remarkable is their modular construction method, which enhances production efficiency and reduces build time to just 7 years per unit. But is it just size and technology that set them apart? Absolutely not. These submarines are equipped with state-of-the-art weapon systems, enabling them to perform everything from anti-submarine warfare to intelligence gathering, making them undetectable, silent assassins in both coastal and deep-sea missions. With their ability to remain submerged indefinitely and carry Tomahawk missiles capable of striking targets thousands of miles away, Virginia-class submarines are not just tools of war. They are a declaration of American power in the 21st century. The advancements in Block 5, including the capacity to carry an additional 28 cruise missiles, will further solidify these submarines' critical role in future conflicts. What do you think about the Virginia-class submarine's impact on the global arms race? Share your thoughts in the comments. The Virginia-class submarines are leading a revolution in U.S. naval design and operational efficiency. Did you know that these submarines are now built in just 4 sections instead of the previous 10? This innovation not only reduces production time, but also cuts costs by up to $300 million per submarine. Additionally, Block 2 submarines were produced under a multi-year procurement contract, saving another $400 million, approximately $80 million per unit. This is an unprecedented cost-effective strategy in submarine manufacturing history. Are you curious about the groundbreaking improvements in Block 3? These submarines feature the Large Aperture Bow (LAB) sonar system, a horseshoe-shaped array that replaces the traditional spherical sonar system used since the 1960s. The LAB system is not just more advanced, but also incorporates technology from the Ohio-class SSGN submarines, including 2 vertical launch system VLS tubes, each capable of holding 6 Tomahawk cruise missiles. This is not just an incremental upgrade, it is a leap forward in modern submarine warfare capabilities. In 2014, General Dynamics Electric Boat secured a $17.6 billion contract to build 10 Block 4 submarines, marking the most expensive submarine contract in history. Beyond improving operational capabilities, Block 4 reduced the number of major maintenance periods from 4 to 3 throughout the submarine's lifetime. This translates to significantly increased operational availability, providing unmatched value to the U.S. Navy fleet. However, the pinnacle of technological advancement lies in Block 5, the latest model. Measuring 461 feet in length and weighing 10,200 tons, Block 5 is designed with the Virginia Payload Module, VPM, allowing it to carry more missile launch tubes. Powered by a nuclear reactor, the submarine can travel underwater at speeds exceeding 29 miles per hour and operate beneath the ocean's surface for months without surfacing. The Virginia-class submarines stand as a symbol of American military technological superiority. Now, with the Virginia Payload Module, VPM, they have entered a new era. VPM is more than just a technical upgrade, it is a revolutionary leap forward. It enables these submarines to carry additional attack missiles, filling the gap left by the retiring Ohio-class guided missile submarines, SSGNs. For the first time, VPM will be installed on the second Block 5 submarine, designated SSN 803. This upgrade is what transforms Virginia-class submarines into a true silent assassin along coastal regions. Did you know that VPM isn't just about cruise missiles? This system is poised to become a strategic game-changer as it is deployed on Block 5 Virginia-class attack submarines, set to join the U.S. Navy fleet in 2025. According to reports from the U.S. Navy, with VPM, each submarine will be capable of carrying up to 40 Tomahawk cruise missiles, doubling the offensive power compared to previous versions. Additionally, the Pentagon has confirmed that starting in 2028, VPM will integrate hypersonic missiles, weapons capable of traveling 5 times the speed of sound, allowing them to strike targets thousands of miles away within minutes. The Defense Advanced Research Projects Agency, DARPA, has also emphasized that hypersonic missiles are a critical component for maintaining strategic superiority in future conflicts. But the advancements don't stop there. By 2030, VPM will support the deployment of underwater unmanned vehicles, UUVs. According to the U.S. Naval Institute, these UUVs will be capable of conducting reconnaissance, surveillance, and electronic warfare missions, providing an unparalleled advantage in undersea operations. Most notably, by 2040, VPM will integrate advanced sensors and unconventional warfare systems, transforming Block 5 submarines into true multi-role combat hubs, capable of sabotage, intelligence gathering, and even cyber warfare. What if each submarine could double its capacity to eliminate coastal targets? That's exactly what Block 5, whose construction began in 2020, is designed to achieve. With General Dynamics' Electric Boat leading the effort, each Block 5 submarine is equipped not only with VPM, but also with 12 Vertical Launch System (VLS) tubes for Tomahawk cruise missiles, along with 4 21-inch torpedo tubes for Mech 48 torpedoes or UGM-84 Harpoon missiles. In total, each submarine can carry up to 65 torpedoes and missiles, an immense underwater arsenal. Looking back to 2003, when the first SSN 774 class submarine was introduced, the Virginia class has consistently demonstrated its lethal power. Block 1 featured 12 VLS tubes for land attack Tomahawk cruise missiles, along with 4 MiG-48 torpedo tubes. By Block 3, improvements replaced the VLS system with 2 Virginia payload tubes, each capable of holding 6 missiles. However, the ultimate leap in firepower came with Block 5, which introduced VPM, adding 4 large vertical launch tubes midship. Each of these tubes carries 7 Tomahawks, bringing the total capacity to 40 missiles, turning the submarine into a true floating missile platform. What makes the Virginia Block 5 submarine one of the most formidable weapons in the U.S. Navy? As the latest upgrade in the fast attack nuclear-powered submarine series, Block 5 boasts groundbreaking enhancements, raising a crucial question: where does its true power come from? Compared to its predecessors, Block 5 is significantly longer, increasing from 377 feet to 459 feet, with its displacement surging from 7,800 tons to 10,200 tons. Equipped with 4 massive vertical launch tubes, each capable of holding up to 7 Tomahawk cruise missiles. Block V can carry a total of 40 missiles. This not only enhances its capability to strike land-based targets, but also cements its status as an invisible assassin lurking beneath the deep ocean. Did you know that the Block 5 deployment plan is one of the largest contracts in U.S. Navy history? Valued at $22.2 billion, this contract includes the construction of 9 submarines, 8 of which will be equipped with the Virginia Payload Module, VPM. These submarines are scheduled for delivery between 2025 and 2029, with the expectation of shaping the future of global naval forces. These advancements make the Virginia Block 5 the most powerful attack submarine ever deployed by the U.S. Navy, with an expected service life extending into the 2070s and beyond. However, the strength of the Virginia class is not just about weaponry. With the ability to dive deep, maintain absolute silence, and strike from over 1,000 miles away, these submarines can penetrate enemy territory without detection. They are masters of evasion and destruction while remaining completely anonymous. This is precisely why the only real adversary of a nuclear submarine is another submarine, and the Virginia class may be the best at this role. Consider this. Why did Australia decide to replace its fleet of Collins-class diesel-electric submarines with 5 Virginia-class submarines? This decision not only demonstrates the Virginia's formidable power, but also underscores its irreplaceable role in global military strategy. Beyond that, the U.S. Navy continues to expand its capabilities with newer variants. On September 14, 2024, USS New Jersey, SSN 796, a Block 4 submarine, officially entered service, marking a milestone in submarine design as the first to integrate living spaces and amenities suitable for both male and female crew members. Designed for operational versatility, this submarine is capable of handling a wide range of missions, including anti-submarine warfare, ASW, anti-surface warfare, land attacks, and support for special operations. With its cutting-edge weapon systems, New Jersey carries up to 40 Tomahawk cruise missiles, allowing it to launch precise strikes on targets thousands of miles away. Additionally, it is armed with Menk 48 ACAP torpedoes, highly lethal weapons capable of neutralizing enemy submarines and warships even in complex combat conditions. One of the most notable features of New Jersey is its exceptional stealth capability. The submarine is designed with advanced noise reduction technologies, including a sound-absorbing hull and a pump jet propulsion system, minimizing noise emissions and making it virtually invisible to enemy sonar detection. Do you know which submarine was specifically designed to accommodate both male and female crew members? The answer is USS New Jersey. With a displacement of up to 7,000 tons and a length of over 348 feet, it is the first Virginia-class submarine equipped with facilities for both genders, an achievement proudly announced by the U.S. Department of Defense. But what led the U.S. Navy to change its stance? In 2010, the ban on women serving aboard submarines was officially lifted, marking the beginning of a new chapter for women in the submarine force. Today, more than 700 women are serving on submarines, according to U.S. Navy data. By the 2030s, the U.S. Navy will enter a new era with plans to upgrade the Virginia-class submarines to maintain fleet superiority. But did you know that the current production rate of the Virginia-class poses a significant challenge? To address production costs, the U.S. Navy and the Defense Advanced Research Projects Agency, DARPA, are spearheading a groundbreaking program to reduce the cost of attack submarine manufacturing. Some notable advancements include next-generation propulsion technology that eliminates reliance on traditional central shafts, external launch capabilities for weapons outside the submarine's hull, and optimized structural designs to minimize mechanical and electronic complexity. Additionally, automation plays a crucial role in reducing crew workload, enhancing operational flexibility. This is a major leap forward. Can you imagine the strategic impact of these innovations? One of the standout features of Virginia-class submarines is the Universal Modular Mast, UMM, an advanced design developed by L3 Harris Keogh. The UMEM integrates various antenna and sensor systems, including a snorkel, 2 photonic masts, communication antennas, radar, and an electronic warfare mast. What makes this system unique is its modular design, allowing for easy replacement and upgrades. This class of submarines was the first to eliminate traditional periscopes in favor of cutting-edge photonic sensors, including high-resolution cameras, infrared sensors, and integrated laser rangefinders. Interestingly, the original photonic masts had a distinctive shape that made Virginia-class submarines easily recognizable. To address this, the Navy is replacing them with low-profile photonics masts, LPPM, designed to resemble traditional periscopes, thereby reducing detectability. A particularly promising advancement is the non-rotating affordable modular panoramic photonics system, which enables submarines to simultaneously observe a full 360-degree view of the ocean surface. Another crucial component of Virginia-class submarines is the pump jet propulsor developed by BAE Systems, a powerful, ultra-quiet propulsion system. Combined with an open sonar array architecture, it allows for rapid hardware and software upgrades. The submarine's sonar suite comprises multiple advanced systems, including the BQQ-10 spherical sonar array at the bow, ultra-lightweight fiber optic sonar, high-frequency hull-mounted sonar, and the low-cost conformal array, LCCA, on both sides of the hull. These technologies form an impenetrable acoustic barrier, allowing the submarine to detect and track targets with extreme precision. So, does the Virginia-class submarine truly deserve the title of Silent Assassin of the Deep? Drop a 1 in the comments if you agree. When people think of Virginia-class submarines, they often focus on their formidable offensive capabilities. But did you know they also feature cutting-edge rescue systems, such as the MEMC-11 submarine escape gear? This system enables the crew to evacuate from a sunken submarine at depths of up to 600 feet, a remarkable achievement in underwater safety technology. Additionally, an advanced atmospheric monitoring system uses lithium hydroxide canisters to remove CO2, ensuring clean air inside the vessel. To guarantee precise location tracking during emergencies, each submarine is equipped with an emergency position indicating radio beacon, EPIRB, a true life-saving feature. What if these submarines were equipped with laser weapons? According to publicly available budget documents, the Virginia-class is projected to integrate high-energy laser systems with power outputs ranging from 300 to 500 kilowatts, mounted within the optical mast. These lasers are not only incredibly powerful, but also travel at the speed of light, 186,000 miles per second, making it virtually impossible for targets to evade. From UAV and anti-ship missiles to even small warships, these lasers could destroy threats in mere seconds. Even more astonishing is the cost-effectiveness of laser weaponry. Each shot costs less than $1, an almost inconceivable figure compared to the tens of thousands of dollars spent per conventional missile launch. One of the biggest advantages of laser systems is their flexible design. Without the need for traditional ammunition storage, Virginia-class submarines could free up 40% of onboard space, making room for additional high-tech systems. Imagine a submarine capable of operating continuously for 90 days underwater without resupply, all while remaining combat-ready thanks to its onboard laser weaponry. In recent tests, the Virginia-class submarine's laser weapon system achieved a 98% success rate in neutralizing moving targets. This raises a critical question. Could laser weapons completely redefine the way we perceive underwater warfare? With plans to deploy at least 20 Virginia-class submarines equipped with laser weaponry by 2030, the answer seems clear. The U.S. Navy is gradually creating an invisible fleet, not only difficult to detect, but also possessing formidable offensive and defensive capabilities. This marks a major leap forward, harnessing power from the submarine's 30-megawatt nuclear reactor to provide an unprecedented level of defense against modern threats. Additionally, to enhance operational efficiency, these submarines have replaced hydraulic electric control systems with advanced fiber optic control technology. They are also equipped with the Command and Control System Module, CCSM, a Caterpillar 3512B V12 marine diesel engine for auxiliary power, and an integrated escape chamber that accommodates up to 9 personnel. But why did the U.S. Navy develop the Virginia-class submarine? The story dates back to the 1980s, when the Los Angeles-class submarines, first launched in 1976, struggled to compete with next-generation Soviet submarines like the Akula class. In response, the U.S. Navy opted for the advanced Seawolf-class submarines, each costing an astonishing $3 billion. However, due to the enormous cost and the end of the Cold War, only 3 Seawolf-class submarines were ever built. By the 1990s, naval strategy had shifted. Instead of focusing on large-scale oceanic battles in the North Atlantic, the U.S. Navy prioritized coastal operations, particularly in regions like the Persian Gulf. It was in this context that the Virginia-class submarine was born, combining versatility, cost-effectiveness, and superior combat capabilities. What do you think about the decision to replace the Seawolf class with the Virginia class? Was this a wise long-term strategy for the U.S.? By transitioning from expensive Seawolf-class submarines to the more efficient and multi-purpose Virginia-class submarines, the U.S. Navy demonstrated its ability to adapt to evolving strategic conditions. But are systems like laser weaponry and fiber optic controls enough to maintain superiority? These are questions not just for military strategists, but for anyone interested in the future of global defense. The U.S. Navy faced significant challenges when the cost of building Seawolf-class submarines far exceeded expectations. To address this, they developed a new class of submarines that were both more cost-effective and easier to manufacture, the Virginia class. These submarines incorporated advanced Seawolf-class technology, but were designed to be more compact and operate at lower speeds. One notable addition is the latest version of the Virginia Payload Module, VPM, with an estimated cost of $4.3 billion per unit. But the real question is, how do Virginia-class submarines compare to their Russian and Chinese counterparts? In 2008, when U.S. Navy experts analyzed China's perception of American submarines, they found that the Virginia class was highly respected for its advanced technology and superior stealth. Have you ever wondered what the true power of China's most formidable nuclear submarine is? Why is the Type 094, also known as the Jin class, considered one of Beijing's most strategic weapons? What is hidden beneath its massive 449-foot steel hull that has the world on alert? Its secret lies in its 12 JL-2 ballistic missile launch tubes, each capable of delivering a missile with a range of 40,500 miles, enough to reach the U.S. West Coast from the East Asian seas. And that's not all. Since 2020, upgraded Type 094A variants have been equipped with JL-3 missiles, which boast a range exceeding 6,200 miles, covering nearly the entire U.S. mainland. This advancement has propelled China from a latecomer in nuclear naval deterrence to a player with global strike capabilities. In June 2024, a Chinese Type 94 submarine surfaced in the Taiwan Strait. Experts believe this event may signal that China has perfected its nuclear submarine and missile technology, demonstrating confidence in deploying and operating strategic nuclear submarines. According to the 2023 China Military Power Report by the Pentagon, the Chinese Navy currently operates at least 6 Type 094 submarines, each measuring 449 feet in length and displacing 9,000 tons. But has the Type 94 truly reached the technological heights of the US or Russia? The biggest concern among military analysts remains its noise levels. Despite China's efforts to improve stealth technology, the Type 94 is still easily detected by modern sonar systems used by American and Allied submarines. According to experts from Navy Power, the noise levels of the Type 094 are comparable to that of the Soviet-era Delta III submarine, a design dating back to the 1980s. Meanwhile, Russia possesses another technological marvel, the Yasin-M-class submarine. According to naval warfare expert Edward Geist, the Yasin-M is the pride of the Russian Navy and a symbol of Russian military engineering. Weighing 13,800 tons, This submarine is designed for devastating long-range missile attacks. Imagine this. The Yasin-M is equipped with 32 missile launch tubes, capable of firing hypersonic Zircon missiles and Caliber cruise missiles, along with 10 torpedo tubes. This makes the Yasin-M one of the most heavily armed submarines in the world. But does superior firepower outweigh stealth technology? Despite its formidable arsenal, the Yasin-M still does not match the noise reduction levels of the Virginia-class submarines. According to Michael Peterson, director of the Russia Maritime Studies Institute at the U.S. Naval War College, the sensor and signal processing capabilities of the Virginia class are what set it apart. Would you agree that in underwater warfare, the ability to hear and detect first is more critical than sheer firepower? Which submarine is the true undetectable ghost of the deep? Russia promotes the Yasin-M as a stealth masterpiece, featuring an improved hull design and advanced acoustic-absorbing materials. At first glance, the Yasin-M appears to be the ultimate underwater phantom, but is its technology advanced enough to evade the cutting-edge sonar systems of the U.S. Navy? On the other hand, the Virginia-class submarines follow a different philosophy. They are not just stealthy, they are designed to seize the tactical advantage. The pump jet propulsion system enables near-silent movement, making Virginia-class submarines almost undetectable by enemy tracking systems. Furthermore, the Virginia-class integrates state-of-the-art sensors and operates in coordination with satellite networks, allowing it to see the enemy before being seen. With unparalleled technological superiority, is the Virginia-class truly the deadliest predator beneath the ocean? One of the standout features of the Yasin-M is its massive arsenal of high-powered weapons. It can launch Caliber and Onyx cruise missiles, as well as the highly publicized Zircon hypersonic missile, which is claimed to reach speeds of Mach 9, making it nearly impossible to intercept. At first glance, does the Yasin-M seem to have the upper hand? Not so fast. The Virginia-class submarines are not just powerful, they are highly versatile. Equipped with the Mk-48 ACCAP torpedoes and Tomahawk cruise missiles, the Virginia-class can strike long-range targets with pinpoint accuracy and adapt its weapon loadout when upgrades are needed. But here's a critical question. If a weapon is powerful but cannot be produced in sufficient numbers, is it truly effective? This is the exact challenge facing the Yasin-M program. Each Yasin-M submarine costs over $3 billion to build and takes years to manufacture, meaning Russia can only produce a limited number of them. The Virginia-class submarine, in contrast, was designed with a focus on both cost optimization and production efficiency. With a price tag of approximately $2.8 billion per unit, the U.S. has deployed more than 20 Virginia-class submarines, forming an unmatched network of naval power. So, who is the true ruler of the seas? The answer seems clear. While the Yasin-M boasts formidable strength and an intimidating presence, it is more like a beast that appears fleetingly. Meanwhile, the Virginia-class submarine is not just a war machine, it is a symbol of resilience and efficiency. What do you think? Would you choose a giant shark like the Yasin-M, or an intelligent predator like the Virginia, always one step ahead and in control of the game? Let us know your choice in the comments below. Surprisingly, the biggest adversary of the Virginia-class submarine is not Russian hunter-killer submarines or Chinese destroyers, but maintenance itself. Can the U.S. Navy keep these submarines operating at peak performance? This is the question that continues to challenge military experts. While the Virginia-class submarines are a technological triumph for the U.S. Navy, they also face significant maintenance challenges. One of the biggest issues is that replacement parts are wearing out faster than expected, particularly commercial off-the-shelf components used to cut costs. Do you think the initial cost savings are worth the trade-off for long-term performance? That's a question the U.S. Navy is still trying to answer. Additionally, the current shipyard infrastructure is struggling to meet the necessary maintenance demands for submarines and other naval vessels. With nearly one-third of the U.S. Navy's 50 attack submarines currently out of service due to maintenance delays, This is a challenge that cannot be ignored. As a result, the next generation of attack submarines is being designed with a key objective: to optimize maintainability, reducing downtime and costs, while ensuring combat readiness. Did you know that the Royal Australian Navy is set to receive 5 Virginia-class submarines from the US? This is not just a sign of strategic partnership, but also a testament to the trust placed in the effectiveness of this submarine class. As of late 2023, the US Navy had commissioned more than 20 Virginia-class submarines and continues to build more. These submarines play a crucial role in long-range strike capabilities and maintaining a US presence in critical maritime regions. At the same time, the US Navy is considering expanding its attack submarine fleet to 72 units, with plans to build 2 Virginia-class submarines per year from 2025 to 2028. However, no shipyard in the US currently has the capacity to meet this production rate. With existing capabilities, only about 1.2 submarines are being built annually. Do you think American shipyards need a major overhaul to meet this ambitious goal? This could be a decisive factor in determining the future of the US Navy's dominance at sea. Despite these challenges, the Virginia-class submarine will remain the backbone of the US attack submarine fleet for decades to come. Continuous upgrades in weaponry and sensor technology will keep these submarines at the forefront, ensuring their stealth capabilities, executing complex missions, and maintaining superiority in naval warfare. Have you ever heard rumors about a classified US submarine project quietly preparing to control 80% of the world's oceans? An audacious $8 billion initiative based on the Virginia-class submarine is rumored to not only redefine underwater military operations, but also usher in a new era of ocean exploration. Could the so-called Aquarius project turn science fiction into reality? The Virginia-class submarine, already an emblem of military power with its ability to dive to depths of 1,600 feet and a displacement of 8,700 tons, is undergoing comprehensive upgrades by the US Navy. With a goal to launch the first Aquarius prototype by 2028, the project is outfitting these submarines with next-generation mini-nuclear reactors capable of generating 50 megawatts of power, allowing for continuous 120-day operations. More than just a combat weapon, Aquarius is designed to self-sustain resources, producing 52,800 gallons of oxygen and 79,200 gallons of fresh water per day, enough to support 300 people for extended missions beneath the ocean. But that's not all. With a 150-square-foot state-of-the-art laboratory, this submarine can simultaneously support 30 research projects, ranging from seafloor geological surveys to the discovery of previously unknown ecosystems. Its advanced sensor array allows for monitoring over a vast 745-mile radius, providing a commanding presence over key strategic waters by 2035. Once a purely military tool, Aquarius is now expected to become a technological and scientific platform that could unlock the ocean's greatest mysteries. Of course, its military capabilities are equally compelling. Armed with 30 Tomahawk missiles, Mark 48 torpedoes, and 10 unmanned underwater vehicles, UUVs, each capable of autonomous operations within a 310-mile range, every Aquarius submarine is a mobile fortress capable of deploying SEAL teams in under 15 minutes. However, such ambitious advancements are not without controversy. With a massive development cost and the potential to completely reshape naval power dynamics, Aquarius raises a pressing question. Is this a technological breakthrough that brings humanity closer to mastering the oceans, or could it escalate tensions and spark unintended conflicts? By 2040, once the entire Aquarius fleet is fully operational, the US Navy is expected to exert influence over up to 80% of the world's oceans. With such revolutionary advancements on the horizon, what does this mean for the Virginia-class submarines in global strategic operations? Will they continue to be America's key military asset, or will they be surpassed by next-generation naval technology? Share your thoughts in the comments below. The Virginia-class submarines are more than just a symbol of modern U.S. military power. They represent pioneering maritime innovation. With their stealth, flexibility, and superior firepower, Virginia-class submarines remain a critical force in ensuring global security across the world's oceans. As naval warfare evolves, one thing is clear: advanced warships like these will always be essential to maintaining peace and stability worldwide. If you're eager to uncover more secrets about cutting-edge weapons and military power, don't forget to subscribe to Navy Power and turn on notifications so you never miss an exciting video. Imagine this: a new American hypersonic missile capable of reaching speeds of Mach 6, over 4,600 miles per hour. But what's even more astonishing is that in recent tests, it not only achieved this speed, but also demonstrated the ability to cover thousands of miles in mere minutes, while evading the most advanced air defense systems. Do you think this could completely reshape the balance of modern warfare? Let's explore with Navy Power. In real-world test missions using advanced bombers like the B-2 Spirit and the B-21 Raider, this hypersonic missile successfully struck strategic targets in simulated combat scenarios. All of this was conducted with support from the USS Gerald R. Ford, the world's largest and most powerful aircraft carrier to date. Its accuracy is astounding, capable of destroying a target with a margin of error of just 3 feet, even under harsh weather conditions and in the presence of electronic interference. This isn't just technology, it's a strategic advantage that positions the United States as a leader in modern conflicts. Do you know what makes this missile stand out? It's equipped with an advanced AI system capable of autonomously selecting the safest flight paths to avoid enemy air defense systems. Additionally, its unique thermal insulation coating allows it to withstand extremely high temperatures while flying at hypersonic speeds, all without being detected by thermal sensors. This is a glimpse into the future of modern warfare. But this is just the beginning. One of the most advanced and powerful hypersonic weapons slated for mass production is the AGM-183A Air-Launched Rapid Response Weapon, ARW, developed by Lockheed Martin. This missile exceeds speeds of Mach 5, over 3,850 miles per hour, and stands out with its exceptional maneuverability. During flight, it can adjust its trajectory to evade air defense systems like Russia's S-400 or China's most advanced systems. Equally significant is the Hypersonic Attack Cruise Missile, HAC, another hypersonic weapon developed by Northrop Grumman, designed for maximum flexibility. Using air-breathing engine technology, the ACAM achieves speeds above Mach 5 and can execute complex flight patterns, making it nearly impossible to track and intercept. This capability allows it to execute precision strikes on mobile targets, even in harsh weather conditions. If one day the US receives intelligence about critical enemy mobile missile systems located thousands of miles away, the AGM-183A would be the perfect choice. With support from advanced bombers like the B-21 Raider, this weapon can traverse vast distances in just minutes to deliver precise strikes on its targets. Meanwhile, the HACM becomes the optimal choice for destroying mobile military bases or other critical strategic facilities. Its maneuverability and advanced propulsion technology enable it to adapt to complex scenarios, even in environments with intense electronic interference. When discussing the Conventional Prompt Strike (CPS) program, its potential in naval warfare is nothing short of revolutionary. Imagine a hypersonic missile launched from a submarine, capable of striking targets thousands of miles away, while the submarine remains completely undetected by the enemy. This is the perfect tool for delivering precise strikes on strategic long-range targets, including the destruction of enemy warships or coastal fortifications. Advancements in hypersonic technology and missile-equipped submarine systems have given the US a significant strategic edge in both deterrence capabilities and long-range offensive operations. So, how will China and Russia respond? If the US launches a hypersonic missile, Russia might activate air defense systems like the S-500, but the problem is that these systems don't have enough time to react. According to experts, even Russia's most advanced systems struggle to detect and intercept hypersonic targets. Meanwhile, China is developing its own hypersonic systems, but remains behind in maneuverability and accuracy technology. Their missiles tend to follow more linear trajectories, making them easier to intercept by US defense systems. This forces adversaries to rethink their strategies, shifting from offense to defense, significantly reducing the risk of conflict escalation. Hypersonic missiles are not just a new type of weapon, they represent a fundamental shift in modern warfare. The US is not only maintaining its leadership, but also setting the new rules for this era. On April 3rd, Lockheed Martin and the US Navy announced a test of the AGM-158C long-range anti-ship missile. During the test, 4 missiles were launched simultaneously and coordinated to strike their target. This wasn't just a routine event, but a turning point. The US now possesses a weapon capable of sinking enemy ships within 3 seconds, leaving no chance for retaliation. So what makes the AGM-158C so terrifying? First, its superior guidance and control systems open new horizons for naval forces. A single missile has the destructive power equivalent to at least 5 conventional missiles from adversaries. Moreover, it is cost-effective relative to its impact, capable of sinking billion-dollar warships. Developed in 2015 and entering service in 2019, the AGM-158C LRASM is regarded as the newest and most powerful anti-ship missile in the world today. Based on the US Air Force's JASSM-ER air-to-surface missile, the AGM-158C LRSM shares a similar appearance but differs significantly in combat capabilities. Compared to the JASSM-ER, the AGM-158C LRSM features smarter guidance systems but has a reduced range of approximately 340 miles. While this range is half that of the JASSM-ER, it is 4 times greater than that of the older Harpoon anti-ship missile. Equipped with a warhead weighing nearly half a ton, the AGM-158C LRASM can easily disable surface warships weighing up to 10,000 tons with a single strike. Another key advantage of the AGM-158C LRASM is its ability to be launched from the standard M41 system on most modern cruisers and destroyers. The missile is powered by a jet turbine engine, similar to those used in fighter aircraft, allowing it to fly at speeds of over 800 miles per hour at low altitudes, skimming the surface of the sea and making detection nearly impossible. Even a C-17 transport aircraft can carry and deploy up to 45 missiles in a single flight. Each missile is equipped with artificial intelligence and a 990-pound warhead, enabling it to execute strategic, national-level missions. Why is the AGM-158C so powerful? This missile doesn't just rely on old designs. It has been upgraded with advanced radar, artificial intelligence, and the ability to coordinate with other missiles. It can autonomously identify the location of enemy ships, pinpoint weaknesses, and strike critical areas such as engines or decks. This technology isn't just a military leap, it's a psychological threat to adversaries. Have you ever seen a weapon that combines artificial intelligence, hypersonic speed, and pinpoint accuracy? Share your thoughts in the comments below and let Navy Power know. The AGM-158C is equipped with highly sensitive sensors, enabling it to precisely target specific points on a ship to inflict maximum damage. For instance, it can identify vulnerabilities such as engine compartments or exposed deck sections, and strike those areas to cause the greatest destruction. Even more impressive, this missile can be launched from any modern fighter or bomber, including the F-35C, the most advanced hypersonic aircraft in service today. But it gets even more exciting. One of the most innovative uses of the AGM-158C is through the Rapid Dragon system, where missiles are loaded onto special pallets. This system allows transport aircraft, like the C-130 or C-17, to transform into true combat machines. Just imagine, a single C-17 can deploy 45 AI-powered cruise missiles in one launch. How would an enemy react when faced with a rainstorm of missiles descending from the sky? This missile is also equipped with a 990-pound warhead, specifically designed for armor penetration. Even the largest aircraft carriers would struggle to survive such an attack. However, in most cases, enemy warships rely on defense systems like Aegis or heavy machine guns for protection. But this is where things get interesting. The AGM-158C has a range of 250 miles, far enough to be launched from beyond the reach of air defense systems. It then dives close to the water's surface, transforming into an invisible phantom. This capability provides a dual advantage, both strong defense and powerful offense. Yet, even with advanced skills and modern air defense systems, intercepting the AGM-158C is extremely challenging. With speeds exceeding 800 miles per hour, approaching hypersonic speeds, it poses a significant threat to any naval defense system. The strength of the LRASM lies in its advanced guidance system, which is highly resistant to jamming. This system integrates mid-course corrections via signals from the launching vessel and waypoint navigation, making the LRASM's flight path highly unpredictable and difficult to intercept. In its terminal phase, the American anti-ship missile utilizes an active radar seeker and an optical infrared sensor to maximize its accuracy, even in adverse weather conditions and strong electronic warfare environments. Additionally, the LRAM employs a new aerodynamic design combined with composite materials and radar-absorbing coatings, granting it stealth capabilities and making detection and interception exceptionally difficult. With a fragmentation warhead weighing approximately 450 kilograms, 990 pounds, the LRASM can easily disable surface warships weighing up to 10,000 tons within its effective range of about 340 miles, nearly double the range of current Harpoon anti-ship missiles. Lockheed Martin also developed a hypersonic speed variant of the LRASM, but technical challenges and high costs led the Pentagon to decline deploying this specialized version. In addition to its anti-ship capabilities, the LRASM is also equipped to destroy land-based targets and can be launched from standard MK-41 vertical launch systems used on most NATO-compliant warships today. The U.S. military envisions the LRASM as the standard anti-ship weapon for both the Air Force and Navy. Many allied nations have also shown interest in equipping their forces with this stealth anti-ship missile. The LSM system features a guidance system developed by BAE Systems, integrating anti-jamming GPS and IS, infrared seekers with automatic target recognition, radar warning receivers RWR, and passive electronic support measures ESM. The multi-mode guidance system ensures the missile can hit its intended target, even if the target attempts to disrupt the guidance system. The AI software onboard the missile utilizes all available weapon functions to detect targets, and multiple LRASMs in flight can exchange information while targeting, forming a highly stealthy group of missiles. Aside from its low-power RF emissions for these communications, the LRASM emits no electromagnetic signals, reducing its radar cross-section RCS and enhancing its low-infrared IR signature design, making it even harder to detect. Currently, the LRASM is only deployed on FA-18E/F Super Hornets and B-1B Lancers, but the Navy is working on integrating it into P-8 MPA, maritime patrol aircraft, and has plans to equip it on future P-35 MPAs and F-35 fighters. The ongoing efforts to integrate the stealth LRASM onto F-35 fighters highlight the U.S.'s commitment to enhancing the anti-ship capabilities of its most advanced combat aircraft fleet. For the first time, the U.S. released an image showing the stealth fighter F-35 carrying the air-launched AGM-158C LRASM stealth anti-ship cruise missile, as reported by the War Zone on September 24th. With the AGM-158C LRASM, the F-35 fighter will gain anti-ship combat capabilities for the first time, which is considered a critically important capability for potential high-level conflicts in the future. According to the War Zone, TWZ, the photo released by the U.S. Department of Defense on September 24th depicts a test flight conducted from Naval Air Station Patuxent River, Maryland, on September 10th. In the image, a pair of LRASM, long-range anti-ship missiles, can be seen mounted on underwing pylons of an F-35C carrier-capable variant assigned to the F-35 Lightning II PAX River Integrated Test Force, PAX ITF. As part of ongoing integration efforts, the PAX ITF team conducted 2 days of flight testing to evaluate vibration, load, and flight quality with 2 AGM-158 missiles mounted on external hardpoints, the report stated. A derivative of the AGM-158 GEM air-launched long-range cruise missile, developed by DARPA Defense Advanced Research Projects Agency under the U.S. Department of Defense, the AGM-158 SEM shares the same design mold as the GEM. In addition to the F-35C, the LM will also be integrated into the F-35 short takeoff and vertical landing KUL variant. Although the LRASM, like the JASM, cannot be carried internally on any F-35 variant and must be mounted externally, which negatively impacts the aircraft's stealth capabilities, it offers the advantage of long-range precision strike capability. Moreover, the stealth capabilities of the LRASM itself enhance the survivability of this perfect pair. According to its manufacturer, Lockheed Martin, the LRASM reduces reliance on ISR, intelligence, surveillance, and reconnaissance platforms, network links, and GPS in dense electronic warfare environments. This advanced guidance capability means the missile can utilize raw targeting data to locate and destroy predetermined targets, even in denied environments. The precise lethality against both surface and land-based targets ensures that the system will become a critical addition to the U.S. Navy's arsenal. The LRASM provides range, survivability, and lethality unmatched by any current system. Current efforts to integrate the stealth LRASM onto F-35 fighters reflect the Pentagon's determination to enhance the anti-ship capabilities of its most advanced combat aircraft fleet. With a focus on addressing unforeseen future scenarios in the Indo-Pacific region, there is significant interest in developing and deploying a range of new land-based ground-to-ground missile systems with anti-ship capabilities, as well as air-launched weapons like the LRASM. NAVAIR, Naval Air Systems Command, is currently working on integrating the AGM-158C1 LRASM long-range anti-ship missile into the U.S. Air Force's F-15E Strike Eagle and F-15EX Eagle II, providing these aircraft with a new tool for targeting surface ships. The U.S. Air Force's F-15E Strike Eagle and F-15EX Eagle II fighters will now be equipped with the AGM-158C1 LRASM long-range anti-ship missile, enabling the Air Force's aircraft to strike surface targets. This development was officially announced by the U.S. Navy's NAVAIR, Naval Air Systems Command, which is overseeing the program to adapt the LRASM anti-ship missile for the U.S. Air Force's fighter-bomber aircraft. NAVAIR announced its intent to negotiate and subsequently award a cost-plus-fixed-fee (CPFF) contract to Lockheed Martin Missiles and Fire Control (LMFC), which will include integration and testing support for the AGM-158C1 missile on the F-15EX aircraft platform. This requirement also includes the integration of the AGM-158C1 UAI interface. While it has long been known that the F-15E has the capability to employ the AGM-84 Harpoon anti-ship missile, this weapon no longer appears to be part of the Air Force's arsenal for the F-15E. Even if it were, the range of this weapon is significantly shorter than that of the next-generation LRASM, and the older AGM-84 Harpoon lacks stealth capabilities. The integration of the Harpoon missile was performed on prototype F-15Es for export customers, similar to the F-16. Two countries currently using both the AGM-84 and F-15 are Saudi Arabia, which operates the F-15SA and AGM-84L Harpoon Block II, and South Korea, which operates the F-15K Slam Eagle and AGM-84H Stand-on Attack Missile Expanded Response (SLAM-R). The F-15E Strike Eagle is one of the primary platforms for the U.S. Air Force's AGM-158 JASM giving it the capability to launch air-launched cruise missiles to strike ground targets. The F-15E also operates the JASSM, so integrating the LRASM, which shares the same external design as the JASSM, makes logical sense. In fact, the F-15E has demonstrated the ability to carry up to 15 JASSMs, whereas the F-15EX is currently capable of carrying 12 missiles. The F-15E and F-15EX models are all-weather multi-role strike fighters, part of the McDonnell Douglas F-15 aircraft family. As the newest fighter bomber in the U.S. Air Force's fleet, the F-15EX was acquired to complement the F-35A and replace the aging fleet of F-15CD aircraft. It is expected to perform regional air defense and air superiority missions while also serving as a platform for long-range weapons like the JASSM or LZM. In today's context, missiles like the AGM-158C are becoming the U.S. Navy's ace in the hole. Warships like the Arleigh-Burke-class destroyers and Ticonderoga-class cruisers not only boast a powerful arsenal of long-range weapons, but are also equipped with advanced electronic systems, ensuring seamless communication and coordination with Allied ships. These ships can deploy drones for reconnaissance and long-range strikes on targets. However, there's a major challenge. Modern U.S. warships, despite their long-range strike capabilities, cannot reload missiles while at sea. A 2019 study revealed that, in the event of a large-scale conflict in the Pacific, the U.S. Pacific Fleet might require up to 10,800 missiles per month. This means that warships would frequently need to return to port to restock, leading to extended downtime and reduced combat readiness. So, what's the solution? Fleet modernization programs are focusing on addressing this issue by enhancing the weapon-carrying capacity of destroyers and cruisers and improving the deployment of new weapon systems like the AGM-158C. This missile can be carried by virtually any fighter aircraft, including transport planes. As a result, warships don't need to return to port as often, since aircraft can quickly and efficiently deploy missiles. The U.S. Navy also operates support ships, known as oilers, which provide refueling and fresh supplies like food and produce to warships directly at sea. This system not only reduces the time ships need to return to port, but also enhances the fleet's ability to sustain continuous operations. The AGM-158C, a perfect complement to the power of Ticonderoga-class cruisers and Arleigh-Burke-class destroyers. It not only enhances offensive capabilities, but also makes these warships safer. The biggest weakness of cruisers lies in their ammunition storage, where a precise hit could trigger a chain reaction and destroy the entire ship. However, with the introduction of the AGM-158C, the number of missiles stored on ships can be reduced, allowing the U.S. Navy to focus on enhancing other defense systems, such as air defense and anti-torpedo measures. So how does the AGM-158C work? Warships use their most powerful radar systems to detect targets and then relay the coordinates to the AGM-158C's central control system through a secure communication channel. When a fighter jet launches the missile, the AGM-158C flies toward the target at high speed and strikes with a powerful warhead capable of penetrating the protective armor of enemy ships. This is not just a weapon, it is a statement of America's superior position in today's global landscape. The development of the AGM-158C is one of the most strategically significant decisions made by the U.S. Navy. This missile not only strengthens naval power, but also optimizes tactics in global operations.